So our second day of transformations, we're going to look at all the vertical ones. Since they're both pretty easy, we're going to do both the vertical ones in the same day. I did phase shift by itself because that was the first day and we had kind of go through the background stuff. But now that we've done that, we'll do these two together. Okay, remember the plan, I think, is still going to be to finish all the material tomorrow. And then Thursday, we'll do a review day. And then Friday, we have this class for an hour. So I think that'll still be enough time to take the test. If we finish all the material Wednesday and people aren't 100% sure it'll be enough time, we could always review for like the first half of class on Thursday and then start the test in the second half and then finish it Friday. So that could be an option too. Right. But we can talk about that. All right, so let's first talk about amplitude. Okay, so what is amplitude? Well, amplitude is basically the height of a sine or cosine wave. And what I mean by the height is the distance that the peak of the wave is off kind of that center line. Okay, that's the amplitude. And the wave is symmetrical, so the distance from the low point of the wave up to that line should also be the same. Exactly the same. So if the amplitude is measuring the distance from the center line to the highest point, what kind of number do you think amplitude always has to be?
Positive?
Yeah. And we're going to mention that, but amplitude is always a positive number. Yep. Now, this is just another name for a vertical stretch. When we do a vertical stretch, there's a number in the problem somewhere. Is it usually on the inside of the parentheses or on the outside?
Outside.
It's on the outside. The vertical is always on the outside. And is it usually multiplication or addition, subtraction?
Addition, subtraction.
Multiplication. So when we do addition or subtraction, that's a shift. Okay. When you do multiplication, that's a stretch. Right? Like if you had x squared versus 3x squared. That's a vertical stretch by a factor of 3. If you did x squared plus 3, that's a shift up 3. Okay, so it's going to be multiplication, and it's going to be in front. Right? So that's what an amplitude change looks like. It's a vertical stretch. Okay, and you know what? I'm going to just change the letter that I use. You can use that letter, but I want to use the letters in the order that they're going to go. So A, B. So this would be C. It's the third transformation you would do when you put them all together. So there's an example of a vertical stretch. 3 sine x. All right, so if I graph sine x and 3 sine x, how do you think 3 sine x is going to look?
Yes. The wave is just going to be taller.
Yeah, it's going to end up being 3 times as tall. Okay, so there's your original. The new one is still going to cross the x-axis at exactly the same spots. It's just going to go higher and lower. But that's a graph of 3 sine x. Okay. How about that one? -2 cosine x. Okay, we've talked about having a negative here. What does a negative do when you put it with the number that stretches? Yeah. Yeah, it's going to flip it. So this one does 2 things. It stretches it twice as big, and then it flips it. All right, so what does a graph look like when you flip it? Well, let's just do 3 sine x, and then we'll flip it. -3 sine x. Okay, so here's an original, and here's what you get when you flip it. Okay, when you flip it, the high point becomes the low point, and then the low point becomes the high point. Everything switches place.
Yeah. Technically, isn't that just moving the graph high over to left or right?
So if you just looked at that picture, there are multiple ways to generate this picture. You could do a reflection, like I did, or you could take the blue graph and shift it to the right or shift it to the left pi units. Yep. So just looking at that picture, if somebody said, how do you turn the red graph into the blue one? There's more than one answer. Yep. All right, how about this one? What's going to be different about this last one? Yep.
The waves are going to be shorter and wider.
Yeah, so this is going to compress it, right? So if you've got, let's just say sine x and 0.5 sine x. Okay, still going to cross the x-axis at all the same points. It's just going to take this wave and compress it. So instead of being between -1 and 1, it's between -0.5 and 0.5. Right, so the same rule that we're used to. When you're doing a vertical stretch, it can get bigger or it can get smaller. So amplitude, I think I said this earlier. Amplitude is a distance, and distances always have to be positive numbers. So if we look at these three problems, actually let's take those three. And let's find the amplitude of all of them. Unless I have one down here. Okay. So just gonna make some lines. And we're going to find the amplitude. So the amplitude, and just to be consistent, I think I use the letter C. It doesn't really matter what letter you use, but let's stick with C. It's the absolute value of whatever number is in front. That's how you find the amplitude. So what would be the amplitude of the first one? 3. It's the absolute value of the number that's in front. So that's 3. How about the amplitude of the second one? 2. Even though there's a negative in there, the negative doesn't affect the amplitude. The negative flips it. But the amplitude is still 2. So negative has an effect on the picture, no effect on the amplitude. And how about the last one? What's the amplitude there? 1/2. What if I did this?
Still be 1/2.
It'd still be 1/2. It would flip, but it wouldn't change the amplitude. And then what if I did something like this?
Still be the same.
It'd still be the same. This is what we talked about yesterday. That's a phase shift. Shifting at left and right has nothing to do with the height. Okay? So when you're finding the amplitude, focus on the number that's in front and take the absolute value. All right, so there's really two things that can happen. The graph can either stretch or it can compress. If you put a number in front that has an absolute value bigger than 1, okay, so numbers like 2, 5, -10, any number that would have an absolute value bigger than 1, it's going to stretch. If you put in a number that has an absolute value of less than 1, that would be a number like 1/3, 0.5, -0.7. Those all have absolute values of less than 1. It's going to compress it. Now, when I said -0.7, it actually does two things. It compresses it and it flips it. But the point is, it still compresses it. Okay, so now we want to start thinking about what is going to change. Right? All the coordinates have an x part, and then they have a y part. We're going to be stretching and compressing vertically. When you stretch or compress vertically, what part of the coordinate changes?
The Y.
Right, the y changes. So you got something like that. And something like that. And let's say you take this graph and you watch the low point of that wave. If I stretch it vertically, it didn't move left and right at all. All it did was move down. Yeah, I didn't stretch it symmetrically. I didn't stretch it that way. But it moved down. Okay, so stretching and compressing will change the y value. All right, so that means all the x's stay the same. What's nice about the x's staying the same is those numbers are harder to work with. Okay, because they're all fractions and they all have pi in them. We don't have to work with those today. What are the normal x's that we use? The 5 x's for sine and cosine. Yeah.
For sine, it's 0, pi over 2, pi, 3 pi over 2, 2 pi.
Yep.
And cosine, it's 0, pi over 2, pi. Oh, wait, no. Wait, yeah. Yeah. 0, pi over 2, pi, 3 pi over 2, and 2 pi.
Right. So those x's that, as I just said, those are going to be the x's in every single problem in the homework. 0, pi over 2, pi, 3 pi over 2, 2 pi. Don't change those for any problem we do today. All right, so if the x's are going to stay the same, then it's going to be the y's that change. All you have to do to find the new y values is multiply the old y values by c. And remember what c is. C is the number that's in front of the sine function or cosine function. To find the new y's, multiply the old y's by c, not the absolute value of c. Okay? Absolute value is only if I ask you for the amplitude. If there's a negative with the c, you need to use it because the negative is going to cause the graph to flip. Yeah.
So no phase shift on the homework today?
No, there are no phase shifts on the homework tonight. No. Just vertical stretches and vertical shifts. All right, so when I put the oscilloscope up yesterday, I showed you kind of like a wave, a couple people like tried making like a whistling sound or just talking. So if you had a sound wave that looked like this, and then you had a sound wave that looked like this, what do you think the difference in how you would hear those two waves would be? Yeah?
The blue one would be a lot higher of a pitch because the waves are taller.
Okay, so it could be one thing. It could be a higher pitch. What's the other thing that could be different about the two sounds? Yeah?
One's loud.
Yeah, one's louder. This one is the volume. So when you stretch it vertically, it makes it louder or quieter. When you have a wave like this, and you stretch it or compress it horizontally,
That's when you hear the higher pitch.
that would be like a higher pitch sound,
Mm-hmm.
and then that would be a lower pitch sound. So we'll talk about that tomorrow. Yeah, but this would be volume. All right, so let's try this one. Okay, so y equals 3 cosine x. All right, so first thing we got to figure out is what kind of transformation it is, because now we know two of them. When you have a number and it's multiplied in front, what kind of transformation is it?
Vertical.
Yep, vertical
Stretch or shrink.
stretch. Yeah, it's going to vertically stretch or shrink it, changing the amplitude. Okay, so when you have a vertical stretch or shrink, what column here stays the same?
X.
X's. And can you remind me, Isaiah, what my X's are?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Perfect. Now, off to the side, okay, outside the box, I'm going to put my original y values for cosine. And then I'll modify them to be 3 times as much. Okay, what are my original y's for cosine? Yeah.
1, 0, negative 1, 0, 1.
1. And what are we going to do to all of them?
Multiply by 3.
Yep, you're going to multiply them all by 3. So what are going to be my new y values?
3, 0, negative 3, 0, 3.
Yep, those are your new y values. Okay, so have a good day. Okay, any question on how we got the table? Alright, now all we have to do is graph it. Now, the problem with stretching it bigger and bigger is you could need a bigger and bigger piece of graph paper. Well, to avoid that, what I'm going to do is, instead of going by ones on my y-axis, I'm going to scale it. Okay, I need to go as high as 3, and I need to go as low as negative 3. So that's how I'm going to scale it. This will be 0, 3, and negative 3. So because I'm scaling my y-axis, it's not going to look any bigger because I changed my scale. Any questions on that? Okay. So now, label your x's. 0, pi over 2, pi, 3 pi over 2, 2 pi. And I'm just going to zoom out so I can see my table and fill them all in. So we got 0, 3. What's my next coordinate?
0, pi over 2, 0.
Pi over 2, 0. Yep, next one.
Pi negative 3.
Pi negative 3. Okay, and second to last one.
3 pi over 2, 0.
Perfect. And my last one.
2 pi 3.
2 pi 3. All right, and now just make your wave. And that's 8. Now, if I had to graph 30 cosine x, I would use exactly the same picture. All I would do is this. Now that's the graph of 30 cosine x. So I just change my scale to whatever I need. All right, any questions on the table or on the sketch? All right, so that's a cosine that's stretched. Let's try a sine that shrinks. Okay, it's not going to look like it shrinked because I'm going to change my scale. Okay, so first step, what tells us that this is a, well, what tells you the kind of transformation this is? Yep.
The 1/2 being in front of the sin.
And what operation are you doing?
This is a shrink.
So like what math operation now? What arithmetic?
Multiplication.
Multiplication. It's multiplication. That tells you it's a stretch. And it's in front. That tells you it's a vertical. So vertical stretch. Okay. So what column is going to stay the same?
X.
Which one? Yes. X's are going to stay the same. And what are my x values?
0, pi over 2, pi, 3 pi over 2, and 2 pi.
And 2 pi. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, are those going to change in any of the problems for tonight? No, those are always going to be the same. Alright, so here's going to be my table. Now off to the side of the table, I'll put the original y values for sine. And what are my original y values for sine?
1, 0, negative 1, 0, 1.
Okay, 1, 0, negative 1, 0, 1.
Never mind.
Yeah, what are those?
Is it 0, 1, 0, negative 1, 0?
Yeah, what were the first ones you gave me?
Like cosine.
That was cosine. Yeah. So 0, 1, 0, negative 1, 0. All right. And what do we have to do to all those values?
Multiplied by 1/2.
Multiply them all by 1/2. Yep. Or you could just divide them all by 2. So Alex, once I do that, what are my new y values going to be?
Your first one is going to be 0.
Mm-hmm.
Can I take a check real quick?
Yeah, do you know the next y value?
0.5.
0.5. Yeah.
Okay.
Yeah. You're good.
Okay.
Okay, the next one?
0.
0.
Negative 0.5.
Yep.
0.
Those are our y values. That's it. Okay, so very, very simple arithmetic, at least compared to having to work with pi and finding common denominators and all that stuff. Any question on the table? Yeah.
Why didn't we do this yesterday instead of the other one?
The other one?
Is it just an order in the lesson?
Yeah, you could really do them in any order. Yeah, you could do them in any order. So I did kind of one of the like harder ones first, 2 easy ones today, and then we'll do a harder. Well, it's not harder, but it's more similar to tomorrow. Tomorrow's more similar to Monday. All right, so let's make our sketch. What's the highest y value
1/2.
and the lowest?
Negative
All right, let's use those. So let's call that a half, negative a half. Okay, put your x's. Pi. All right, and plot your points. 0, half, 0. I didn't put that one. I didn't quite put it as low as I could have. And then 0. Oh, it's not that good. Let me fix that. And there's your sketch. So remember, that's a compression. It doesn't look like it because I changed the scope. Any questions on that one? All right, let's look at the last one. What's the amplitude of that graph? Because there'll be some questions on the test that just give you an equation and say, write the amplitude. Yep.
Negative 1.
1. Yes, the amplitude of that is 1. So is it really changing the amplitude? No, there isn't really an amplitude change here, but the arithmetic that you're going to do is still similar. What's all that's going to happen here?
Reflection.
Yeah, it's just going to be a reflection. So the x's stay the same. Hopefully, as you start to write these enough times, you eventually memorize those x values. Okay, the y values for cosine we already did earlier. And what's going to happen to all those y values? Yeah, they all become the opposite. Negative 1, 0, 1, 0, negative 1. That's it. So now when we sketch it, normally the cosine graph looks kind of like a U shape. This one's going to look more like an N shape. technically, I don't need to change the scale on the y-axis. So if you don't label those -1 and 1, that's okay. But you do need to label these. Because I'm not going by ones on the x-axis. What are we really going by in degrees?
90.
Yeah, you're really going by 90s. Or if you're counting it as radians, you're going by pi over 2s. So, all right, let's plot our points. -1. Pi over 2, we're at 0. 1, 0, and back to -1. Right, and that would keep going on. If you had to draw more cycles, just repeat that pattern. All right. Any questions on that? Okay. So that pretty much covers the vertical stretching and compressing type of transformation. Now I can show it to you what it looks like on the oscilloscope if you want to see it. The wave gets bigger and smaller. Let's take a look. Alright, so here's the graph that shows you, no, that's not the one I want this one. Okay, so it shows you a picture of the sound. And what I'm going to do now is I'm going to play. Alright, let's play
AC 13 from Minecraft, the school mode.
a constant frequency. Let's just play 1,000 hertz. And you see a pretty uniform wave when I did that. Okay, not like what I'm talking. What I'm going to do now is I'll change the volume of it, and you should see that wave stretch or compress vertically. All right, so let me play it again. So I made it softer. Of course, if I talk, it messes up the wave. So you can definitely see it stretching and compressing. Now, when I do it tomorrow, when I change the frequency, you're going to see it stretching and compressing the other way. Okay, but we'll look at that tomorrow. Okay, so let's go back here and look at the last transformation, which is the vertical shift. Okay, when you do a shift, what arithmetic operation is shifting? It's always addition or subtraction, and this is going to be vertical. So where is the addition or subtraction?
Outside.
On the outside, right? It's at the end. And it's the last thing you would always do when you do all of them together. That's why I use the letter D. Okay, so there's some examples of vertical shifts. Which one is shifting up?
What? Or. Oh, the first one.
The first one, sine of x plus 2. So when you have a vertical shift, it's not backwards. I know when we do horizontal, the plus and minus is backwards from what you would think. But with vertical, it never is. Positive is up, negative is down. That's what I just said. So vertical shift will move the function up if you add, down if you subtract. All right, so now we want to think about what's changing in the coordinate. If you move a coordinate up or down, and you don't move it left and right, what changes in the coordinate? If it moves up or down. The y. Yep. So when we take a look at how do we find the 5 coordinates for a vertical shift, the y's are going to change again. The x's are going to stay the same. So that's why I said yesterday those 2 tables that I gave you were very important, because a lot of times, actually every time, you're copying down half that table to do the problem. Okay. So this time you're copying down the x's. So if you haven't really noticed the pattern here, there's 4 transformations. 2 of the times the x's stay the same. I just taught you those today. 2 of the times the y's stay the same. I taught you one of them yesterday. We're going to learn the other one tomorrow. Okay, so if the x's are going to stay the same, then what's going to change? Yep, the y's are going to change. So all you have to do, similar to what we did in the last problem, except instead of adding or instead of multiplying your old y values by a number, you're either going to add or subtract to your old y values. So you do the same thing, except don't multiply, add or subtract. And don't do the opposite. Okay, I know when I taught you phase shift, I said if you see like plus pi, do the opposite. With vertical shift, you never do the opposite. So you've got to remember that. If you do the opposite, you're going to get the y values wrong. As far as this one, I don't really know any direct connection with sound. There isn't really any direct connection. But for all the other ones, there is. Phase shift, amplitude change, and period change. I don't think I did the phase shift yesterday. Sound for you guys. All right, so let's try a couple vertical shifts, and that'll be it. All right, so how do we know that that's a vertical shift?
It's adding 2.
Yep, it's adding, and where is it adding?
After.
Right, it's after it. The only way that this could be a phase shift, you have to have the x and the number in parentheses. Now that's a phase shift. If you do not have parentheses around the x and the 2, it's a vertical shift. Okay, so what column stays the same when we shift up or down? Yep, x's. And what are my x's?
0, pi over 2, pi over 2, 2 pi.
2 pi. And now I need to put my y's. Okay, I'll do the originals off to the side, and then I'll just look at them to figure out my new ones. What are your original y values for sine?
0, 1, 0, negative 1, 0.
1, 0, negative 1, 0. Okay, and what are we going to do to all of them?
Add 2.
Yeah, add 2. So to find the new y values, in this case, add the number that's at the end to all the originals. So add 2. All right. So what are my new y values.
2, 3, 2, 1, and 2.
2. 2, 2, 2, 1, 2. All right, let's graph it and see what it looks like. Okay, I gotta go as high as 3 on the y-axis. That's not that high, so I think I can go by 1, so that'll be fine. And I can put my labels right up against the x-axis because I'm not going to be drawing down in the bottom. Everything is going to be shifted up into quadrant 1. All right. And what's my first coordinate?
0, 2.
Yep, 0, 2. Okay, next coordinate?
Pi over 2, 3.
Pi over 2, 3. Okay, next one?
Pi 2.
Pi 2. Next one?
3 pi over 2 dash 1.
3 pi over 2, 1. And the last one?
2 pi 2.
2 pi
2.
up at 2. Right there. And that's your sketch. All right, now, what if I asked you for the amplitude and I gave you that picture? What's the amplitude?
1.
Yes, the amplitude is 1. Don't confuse the amplitude with the maximum. There's a difference. Okay, amplitude is the distance it goes off that center, which is 1. Now, what if I asked you, what's the maximum value?
3.
3. Yeah, that's 3. Okay. So any question on a sine function shifted up to? All right, let's look at the last one. So cosine function shifted down 5. Now, I put parentheses around the cosine and the x. Does that make it a phase shift? No. Where would the parentheses have to be to make it a phase shift?
Around the x and then negative 5.
Right, around the x and the negative 5, not around the cosine x. Those parentheses don't do anything. We don't even need them. Okay. All right, so what stays the same?
The x's.
Yep, and what are my x's?
0, pi over 2, pi, 3 pi over 2, 2 pi.
2 pi. And what about my original y values? Just be careful that they are for cosine. Anybody give me those?
1, 0, negative 1, 0, and 1.
Negative 1, 0, 1. Perfect. And what are we going to do to every one of those?
You're going to subtract them by 5.
Subtract 5. All right. So what are my new y values going to be?
Negative 4, negative 5, negative 6, negative 5, negative 4.
Yep. Perfect. Since I've got plenty of graph space to go down to negative 6, I don't think you need to scale it. If you didn't have enough, you could scale it. So this will be 0. And the x's, I can put the labels right below the axis because I know my graph is going to be way down this time. So this is 0, pi over 2, pi, 3 pi over 2, 2 pi. And plot your puts. So 0, whoops, I messed all those up, sorry. They're all off by 1. They should have been right there. The axis always has to be 0. You can't make 0 somewhere else, like I accidentally did. Okay, so now what's my first point?
Negative 4. 0, negative 4.
0, negative 4. Yep. And the next one?
1, negative 5. I don't know, pi over 2,
Pi over 2, negative 5. Yep.
Yeah.
pi negative 6.
6,
3 pi over 2 negative 5.
5,
2 pi negative 4.
2 pi negative 4. Perfect. Right, and now just draw your wave. Just like that. Okay, any question on that one? Okay, for some people, and I think I mentioned it yesterday, if you have trouble drawing it, your waves don't seem to look right, remember that this part from here to here should look like it's curved up. And then this part from here to here should curve down. And then it would switch again and curve up and then curve down. That's basically what the sine wave looks like. It just switches curvature as it goes. All right. Any question on it? So those are the transformations that affect the y values. We did one that affected the x's yesterday, and we'll do the other one tomorrow. Okay, so the homework tonight is another worksheet. It's the one right below last night. It's 2.4 part 2. Does anybody need me to show them where it is on the school agenda? No? Okay, so you got about 20 minutes or so. Please use the time to try to start at least one or two of the questions, and then you will have as many to finish. Reminder, I will be after school tomorrow because Thursday is open house.